Harmonic functions or harmonic function. A function phi of xy is said to be harmonic if it satisfies Laplace equation, that is dabba square phi by dabba x square plus dabba square phi by dabba y square equal to 0. This is called a Laplace equation. If a function phi satisfies this equation, then that function phi is called harmonic function. So here we have discussed about CR equation, that is necessary and sufficient condition. So if f of z is harmonic, if f of z is analytic, then functions u and v are harmonic functions and are called harmonic conjugates of each other. So u is a harmonic conjugate of v and v is a harmonic conjugate of u. Note, if f of z is analytic, if the function fz is analytic, then it will be completely expressed in the form of z, that is not depends on z bar. So f of z is independent of z bar, which is conjugate of z. So this is very important thing, that if fz is analytic, then that will be only in the form of z, not in the form of z bar. That is, function is independent of z bar. And second thing, if f of z is analytic, and f of z is of the form u plus iv, where u is a function of xy and v is a function of xy. So if u and v are the real and imaginary parts of this function. So if function is analytic, this is analytic function, then now here this function is in the form of u and v, where u and v are the functions of x and y. That means ultimately this function is in the form of x and y. So to find this function in terms of z, then to find f of z in terms of z, we put x is equal to z and y is equal to 0. That means to find f of z in terms of z, will go along only x-axis, positive x-axis, because this is x equal to 0, or this is y equal to 0, and we put x is equal to z there to get the f of z in terms of z only. Now if the function is analytic and if phi is harmonic function, third note, if phi is harmonic function, that is dabba square phi by dabba x square plus dabba square phi by dabba y square is equal to 0, then dabba square phi by dabba x square plus dabba square phi by dabba y square can be written as dabba square, or 4 times dabba square phi by partial derivative with respect to z into partial derivative with respect to z bar. That is very important note. If phi is harmonic function, then we can write the left hand side of the Laplace equation is in the form of right hand side, that is 4 times dabba square phi by dabba z bar.